330 microfarad 2.5 volt. Do you see we have 2.5 volt and here we have 1.2 volt. So the maximum voltage for capacitors here have to be greater than the output voltage. Never use capacitors with a low voltage than the output. If you want to check whether you have or you get 1.2 volt in this channel, you should take measurement here in this part. Avoid to take measurement in IC pins or in the MOSFET pins in order to avoid the short circuit. Always refer to the power part, as you can see, that is a test point. If, for example, you can't find the part, you can go and check the voltage, this voltage above the inductor. Here we have enable. Do you see enable? Means this one is input. This one also is input to have power good, and this one is the output, as you can see. Do you see? Here we have this signal basically is generated after we get this voltage. Here we have 1.2 volt, the same as we have here, power good. Means this IC, after generating this voltage, it will send this 1.2 volt power good to the SIO or the super IO, telling to them that I am good, I am generated successfully the right voltage, 1.2 volt. Hi everyone, so welcome again to another video. This time we gonna study the chipsets power supply, so please stay tuned because I'm going to teach you about the NOT bridge, south bridge, and also the CPU or the processor power rail and circuits. So let's get started. But please, before diving into the course, make sure you subscribe and you hit the bell icon, and also like the video because your likes motivate me to create in a daily basis more videos for you. And join me in my Patreon page if you want to download this schematic and many other schematics, and of course to enjoy a very unique and exclusive content. So let's get started. So as you can see here, this is basically the NOT bridge circuit. As you can see, we have here the voltage, we have 1.2 volts. This is basically the working voltage for chipsets. And over here also in this channel, because basically we have two channels, this is the first channel, and over here we have the second channel, because in every circuit in the computer or laptop you're gonna find usually or always you're gonna find two channels or more. Of course, for the CPU, as I teach you before, for the CPU you can find 3, 4, or even 5 or more channels. Okay, so here as you can see we have plus VCC and B, means the NOT bridge. So the NOT bridge is the chipset that is connected to the processor, and that chipset is like an interface between the CPU and other component in the motherboard. I'm going to show you here the component. I'm going also to show you how this voltage over here 1.2 volts and also this voltage is generated based on the main voltage 19 volts. Of course you're gonna understand how to track and follow signals, and also I'm going of course to teach you what is exactly the main component or the probable component that are failed in this kind of circuit. Okay, if you have for example a failed circuit like this one, what is the component that you should check first, including for example the IC, the MOSFETs, etc. So I'm going to explain to you all this step by step. So let's begin with components. So let's choose the arrow over here. So let's choose this arrow, for example. The first component we have here, as you can see, the pad. Do you see here we have the power pad? This pad basically is like a test point. Means we use this pad to check whether we have this voltage or not. The same for this one also here. As you can see, we have also the pad in the other side. We have another pad. We have pad 505. This is its reference. So if you want to check whether you have or you get 1.2 volt in this channel, you should take measurement here in this pad. Avoid to take measurement in IC pins or in the MOSFET pins in order to avoid the short circuit. Always refer to the power pad, as you can see, that is a test point. If, for example, you can't find the pad, you can go and check the voltage, this voltage above the inductor, one pin of this inductor, because this inductor basically is a little bit a bigger component. It's not like IC or MOSFET. Or also you can check, as you can see here, the plus of the electrolytic capacitors. Also will find 1.2 volt. Okay, so we have the pad over here. This is the pad. Here we have the serum capacitors. This is the symbol basically for resistor. As you can see, we have 10K. Okay, and the symbol or the reference for resistor you will find always R, as you can see, R, or sometimes PR. And for serum capacitor we have C and sometimes PC. Okay, so here, as you can see, we have basically the electrolytic capacitor. As you can see, this is electrolytic capacitor, or we called it, of course, polarized capacitor. Why? Because here we have plus. It's not like the serum capacitor. Here we have plus and minus. That's why we called it polarized or electrolytic or sometimes chemical capacitor. Okay, so its characteristic, basically we have 330 microfarad, 2.5 volt. Do you see we have 2.5 volt? And here we have 1.2 volt. So the maximum voltage for capacitors here have to be greater than the output voltage. Never use capacitors with a low voltage than the output. The capacitors will be blowed out. Okay, the same, for example, let's check here. We have for this capacitor we have 2.5 volt. Here, of course, plus VCCMP, we will get 1.05 volt. Here we will get 1.05 volt. So we have ceramic capacitors. Okay, ceramic capacitors, we have resistor, we have also here electrolytic capacitor, also the reference is C. Then we have, as you can see here, inductor. Do you see inductor or coil? Here we have L. Always you will find L or sometimes PL as a reference for inductors. Okay, then we have MOSFETs. Here, as you can see, we have two MOSFETs, or we called it basically the power regulators or sometimes switches, but here we called it MOSFETs or power regulators. Okay, the switch, we call the switch the MOSFET that is near to the power or DC jack, okay, in the input. So the reference basically is Q. For the MOSFET we have Q. Here also we have Q. Also for transistor we use Q. And then we have the IC. As you can see, the integrated circuit, the reference always is U. So U is for integrated circuits. So then, of course, here we have other ceramic capacitors over here. So what we have also, we have, as you can see here, the ground. This is basically digital ground. Do you see? Digital ground. So This kind of ground is usually used in the laptop motherboard, and we do digital component, because here we have basically digital component like the IC, the MOSFETs, etc. So there is many types of ground, including digital ground, analog ground, and chassis ground. I already have a video in my channel. You can just go to homepage in my channel and look for the ground. You will find a very important video where I explain all about grounds, and of course I will make in the future other videos about electronic and basically laptop component and symbols and their symbols. Okay, so we have this symbol. This symbol basically means do inputs and outputs. When the symbol, for example this one, as you can see here, goes in this direction, do you see this one? Goes in this direction means this is input. Here we have enable. Do you see enable? Means this one is input. This one also is input to have power good, and this one is the output, as you can see. Do you see? Here we have this signal basically is generated after we get this voltage. Here we have 1.2 volt, the same as we have here, power good. Means this IC, after generating this voltage, it will send this 1.2 volt power good to the SIO or the super IO, telling to them that I am good, I am generated successfully the right voltage, 1.2 volt. The same here also. Normally here we have plus VCC not bridge, or this voltage basically is about 1.05 volt. Also here we should find another power good. Here we have power good, as you can see, that will be generated after, of course, generating this voltage. Here we have this mark, means here not used, because sometimes there is some signals that are not used, but for this kind of IC it needs just one power good, this power good output. Okay, means if this voltage is generated, means this voltage generated, this voltage also will be generated. Okay, so this is basically about the symbols that we are here. So now let's discuss a little bit. So let's change the color of this arrow. For example, let's pick the green color. Okay, and now let's track the signal. So to generate this voltage, basically this voltage plus 1.2 volts. So let's remove this arrow. Okay, no problem. So to generate this voltage, we need, of course, this voltage, the main voltage, 19 volts. So this voltage will pass through these capacitors here. Do you see here we didn't have inductor, but no problem, we have capacitors. Those capacitors basically have as a purpose to eliminate the noise in the circuit and to get here a pure voltage. Then so the voltage will be applied to this MOSFET. Here basically we have the drain, and over here we have the source, and this is the gate. Do you see G means gate? So this IC will control this MOSFET. Do you see here we have drive high? It will control this MOSFET in its gate, and also it will control this MOSFET. Do you see we have drive high and drive low? Okay, so once these MOSFETs are controlled, so the 19 volt will pass to this stage, but we will not get here 19 volt, we will get here 1.2 volt. Okay, here we will get 1.2 volt. Why? Here we have 19 volt and here we have 1.2 volt. So this is basically the control signals. The IC is the responsible for controlling and transferring the voltage from one point to another point. So based on the control signal, we can get here 1 volt, 1.2 volt, we can also get here 5 volt or 3 volt, depending on the type of the IC and MOSFET. Okay, so once we get here, as you can see, 1.2 volts, so this 1.2 volt will go in this direction and also in this direction. So in this direction, it will pass through this inductor in order to increase the current step by step until we get the right current, and also it will pass through this electrolytic or polarized capacitor and also to this capacitor in order to be filtered and pured and to get a smooth voltage. Okay, so in this direction, this is basically the phase in order to sense and to make sure that the output is the right output. Means we get here 1.2 volt, not 1.3 or 1.4 or 1 volt. So let's assume, for example, that we get here 2 volt, not 1.2 volt. So this IC will generate another control signal in order to adjust the output voltage. Okay, so this is basically how this voltage regulators and the control IC works in order to get this voltage. So the same working principle here in this channel also, we have the same working principle, always we have, as you can see. So again, let's choose the green color. Okay, so always we have the main voltage. As you can see over here, we have the main voltage. This voltage will pass, as you can see, through this capacitor and there goes to this MOSFET. It will be filtered, the noise will be eliminated here and then pass through this MOSFET after receiving, of course, the drive high signal. This one also will receive, as you can see, the drive low signal. So why this MOSFET is present here? Basically, the purpose of this MOSFET is the same as the IC. This MOSFET is here, as you can see, it is connected to the ground in order to eliminate the extra voltage or the extra residual current, and in order to get here the right voltage. Okay, so that's why it is connected to the ground, and basically this is one of the most failed component in this circuit, this MOSFET and also this MOSFET, because these two MOSFETs are connected to the ground. So when you get the short circuit here in this kind of circuit, you should always check one of these two MOSFETs. It could be this one. If you get a short circuit in this channel, go and check this MOSFET and also this capacitor, because it is also connected to the ground. In this side, check this MOSFET because it is connected to the ground, and also check this electrolytic capacitor because it is connected to the ground. So if you have, for example, the short circuit, don't go and check the inductor. The inductor can never be connected to the ground. Check the components that are connected to the ground. Okay. So this is a very important tip that I want from you to remember. If you get any short circuit in any circuit, never go and check the component like inductor, for example, or for example like this MOSFET. No, or for example go and check this resistor here. You should always check components that are connected to the ground. If you have a short, you have to check components that are connected to the ground, like the electrolytic capacitor. This capacitor is connected to the ground, so this one could be shorted. Okay, so this MOSFET here is connected to the ground, so this one could be shorted. This one, no, it is not connected to the ground. You can check these two ceramic capacitors. Also, if you have, for example, a short circuit in the side, check this one, it is connected to the ground. Check this ceramic capacitor, it is connected to the ground, and also this electrolytic capacitor because it is connected to the ground, and also you have to check the entire IC. The IC also is connected to the ground, as you can see, okay, through here. Do you see here? As you can see, we have the ground, we have P ground. This IC is connected to the ground over here, so this IC also should be checked. How we can check the IC, if it is good or not? There is a very simple method that I'm going to show you right now, is using your finger. You can just put your finger over the IC. If you feel that the IC is overheated, the temperature is not normal, means 100% the IC is damaged. So this is it, guys. So the component that are failed most in this kind of circuit is the IC, this MOSFETs here that are connected to the ground, and those capacitors. So I hope that you enjoyed the video. Please don't forget to like the video and subscribe for future videos, and of course join me in my Patreon page. You will find this schematic and other schematics. Thank you very much, and see you with another video.